Okay, so graphing when it's not in transformation form. Probably one of the tougher lessons for this semester. It's got a lot going on. You're going to have lots of steps. I think I've got steps 1 through 6 on here, and each one of them are pretty involved. So be sure you're taking notes and writing all this down. Step number 1 is going to be to factor, okay? The purpose of factoring is to help us find all of this other piece of information about our graph. By the way, I am in your Springboard book on page 29-3. We're going to talk about discontinuities. Removable discontinuities is where we have a point. This is the example, I believe, that I'm working. I'm doing it a little bit differently than they do, but you're going to get everything that you need because I think I'm combining 2 different lessons together. However, you can follow my examples, but you should also be able to go back and follow their examples because we're not too terribly different. But anyway, that's where we are, page 453. Okay, so step number 1 is to factor. I've taken the numerator, I factored it. I've taken the denominator, I factored it. That's it. That's step number 1, factor. Step number 2, we're going to find the holes. And you're going to find any holes where you have a common factor, okay? So here are my common factors. My common factors are these 2 right here. You know what we do with those. We take those and we say that we cancel them out, okay? So the simplified version of this problem, f of x right here, the simplified version is going to be x minus 2 over x plus 3. That's the simplified version because the x plus 2's canceled out. But you need those x plus 2's. You take the find holes at the common factors. You set the common factor equal to 0. So you take whatever you canceled out. X plus 2 is the common factor. You set it equal to 0, and you get the x by itself. And so you tell me that we have a hole at x equals negative 2. Well, x equals negative 2 is an entire line. If we don't have a y value to go along with that, then you don't know where exactly the hole is. So to find the hole, after you've set the common factor equal to 0, you now plug that negative 2 back into the simplified version, okay, of your equation. We took this equation, this is f of x in factored form. We took it, we canceled out the common factor, set the common factor equal to 0, found x equals negative 2. Now we're plugging negative 2 into the part that's left after we canceled it out to find out where the y value for our hole is. Okay, so we plug in negative 2, we get negative 4 on the top, we get 1 on the bottom. So that means that we have a hole at negative 2, negative 4. Okay, we don't know much about our graph, but so far I know that if I go to a piece of graph paper, I go to negative 2 and I go to negative 4, I can draw an open hole right there. Okay, so if you go to Desmos and try to graph this, if we type in the original equation, I believe it was x squared minus 4. I probably need parentheses around this. Parentheses. And then divide by, what was it? X squared plus 5x plus 6. X squared plus 5x plus 6. Okay, so I have it graphed right here, and you're going, oh, Professor Burkett, I don't see a hole in that graph. Well, if you go and you put it directly on, I'm having a hard time getting it on there. There, oh, there it is. There it is. -2, it shows you as undefined. I wish I could make that little open hole stay there, but you can see right there that when I drag this graph over -2, at -2, -4, it is undefined. Okay, so that's where the hole is. All right, so that was step number 2, finding the hole. Step number 3 is finding your vertical asymptote. To do step number 3, to find your vertical asymptote, we set the denominator equal to 0, okay? Just the denominator. And of course, we can take the denominator of the simplified form. We don't need that. We've canceled out the 2, so we can keep using the simplified form. You take the denominator, whatever it is, set it equal to 0, solve for x, and we find out that we have a vertical asymptote at -3. Okay, now talk about different discontinuities. Anything that causes this function to be undefined is called a discontinuity. A discontinuity is where we have to pick our pencil up in order to graph it. Okay, so we've got a hole in the graph right there, so we're going to have to skip that. And at x equals, where am I? At x equals -3, we have a vertical asymptote. So I'm going to come over here, and at -3, I'm going to draw a little dashed line to represent my asymptote. Now remember, that's where my graph can't go. Okay, vertical asymptote. So now to finish finding pieces of my graph, I'm now going to find my x-intercepts. I find any x-intercepts simply by setting the numerator and just the numerator equal to 0. So there's the simplified version of my problem. X minus 2, set it equal to 0, solve for x. Okay, and that's telling you where your graph is going to cross the x-axis. So I have an x-intercept at x equals 2. So I can come over here to my graph. Here I am at x equals 2. I can put a dot right there because that's where my graph is crossing the x-axis. Okay? And I'm gathering a whole bunch of clues here as I do all of this so that I can figure out how to sketch my graph. We've kind of cheated and looked at the graph on Desmos, but again, remember this is supposed to be so you can gather all the information without having to look on Desmos. So step number 1 was to factor. Step number 2, find the holes. How do you do that? Set the common factor equal to 0, the thing that you canceled out. Then plug it in. Step number 3 is to find your vertical asymptotes. How do you do that? Set your denominator equal to 0 and solve. Step number 4, find your x-intercepts. How do you do that? Set your numerator equal to 0 and solve. Step number 5 is to find your y-intercepts. How do you find your y-intercepts? Plug 0 in for x. So I took this original equation, not the original equation. I took the simplified equation and I plugged 0 in. Okay, plug 0 in. That's going to tell me where I am on my y-axis. 0 minus 2 is -2. 0 plus 3 is 3. So my y-intercept is at 0 and -2/3. So that's a dot on my y-axis. So I'm going to go over here and 2/3. There's a half. -2/3 is going to be somewhere right around there. 2/3, remember, is 0.6676667. So it's going to be right before this 0.75. Okay. And it looks like I am out of time, so that's a good break. So far, we've got the hole, we've got the x-intercept, we've got the y-intercept. The last thing that we're going to do is the horizontal asymptotes, and that's going to take a while. So this is a great place to stop.